Alright, let's solve the Leetcode problem, and this is the second time recording. Since the first recording, I accidentally pressed the play button in iTunes and all the voice messing up around. So the Leetcode problem is a count the special triplet. So we're given an integer array of nums. So a special triplet is defined as a triplet of indices I, j, and k such that all of these numbers should be within the range of the array length, where I is greater than less than j, and j is less than k, and k is less than n. So number of I and j, number of I is equal to the number of j multiplied by 2. Number of k is equal to number of j multiplied by 2. So we have to return the total number of special triplets in the array. Since the answer may be large, we have to return it modulo something like 10 power 9, like 7. That's 1,000,007. I just saw the better way to write about the huge number in Swift instead of writing like, okay, initially we were writing like this, like plus 7, but there is a very better approach. We can write like 1 e power 9, that's 1 million technically, and plus 7. So let's try to get into the assignment given by the Leetcode. So if I have to write about like what is exactly the triplet meaning, let's consider we have 3 numbers like I don't know how to duplicate this. Alright, this will be the j, and that will be the k. So how do we want? So I and k should be the twice of j. If let me think about it. Alright, let's consider this is a x. J is x in the mathematical format. That should be the 2x. The same for the k. So if I and k is 2x and j is x, that is the one triplet we can find in the assignment. So that's exactly what we are given in assignment 1, which is quite straightforward. So if you multiply 3 with the 2, that becomes the 6 and 3. So yeah, and then we can find the only one triplet. So that is the reason why output is 1 in here. So for the assignment 2, we're given like 0, 1, 1, 0, 1, and 0, 0. And it's the same since anything multiplying with the 1, 0 will be everything will be 0, not the 1. So we're ignoring the 1, and the answer will be I 0, that's the 0 index, 2 index, and 3, which is all triple 0. So whatever the 0 you multiply with the 2, that is exactly the 0. So that's why it's creating the perfect triplet in the assignment 2. So let's go for the assignment 3. That's a little bit complicated. Like we're given like 5 number 84284. So output could be the 2. How do we get the output 2? Let's try to move that aside so we have a better understanding here. And then to find the I and j here, we choose like 0, 1, and 3, which is technically 848. If you multiply the 4 with the 2, that will become the 8. So that is a one triplet. Another is 1, 2, and 4. So that means like if you multiply the 2 with the 2, that will become the 4. So that's the reason why we can output like 2. I am pretty sure like this kind of topic will be the hash map. Exactly. What I can think of is, if it is a hash map, just use the hash map, not think a lot. So if you think a lot, like we're gonna be like messing around with a different data structure. So I was considering like, how about we use something like left frequency? Just call like frequent, not the frequency. That's just bad naming. That will be the integer dictionary. How we keep it is like value and count. The same we're gonna need for the right frequency. Right frequency. I don't know why I keep calling it a frequency. Technically we will be using the, okay, don't call like left or right, just call frequent. We gonna count the possible numbers of frequents in the right frequent first. How do we do it? We just simply do like a frequent of num. Okay, I was thinking like, okay, originally if you are used to the Swift, how we usually write is if let value is it in right frequent of num, then we just straight away update our num plus equal 1. If not, that will be the 1 for our case. But I have a very shorter version for this, so we can simply write like a right frequent of num. The default will be the 0, and then if not, we're gonna do the +1, which is exactly the same as the code I written above. So technically we are scanning through all the array, like how many numbers, duplication of numbers exists in here. So next step will be we are going through like again for the second, I would say like left frequent. So that is what we are doing here. If we find that number exists in the our right frequent, let's call like default is 0. We're gonna minus, like detect the values of the counts, and then I will calculate the pairs in here. So how are we going to calculate the pairs? If let's call like pairs, that will be like a left frequent of num multiplied by 2 is exists in the our like left frequent multiplied by right frequent of num by 2. The default also to 0. So what I'm doing exactly in here is I'm just finding the possible pairs that I could get in the, okay, I could get in the given array. So instead of like scanning the whole arrays again and again, so how can we, okay, let me finish the code first. So if we can find it, I will need the one variable here. Let's call like answer, which is initially 0. And then I will update the answer with the pairs and then modulo of our given value. After that, I will remove the value from the, not the remove, is like since we remove from the right, we need to put that back to the left. Let's call like num, and then default will be 0 plus equal to 1. And then we just simply return the answer. Alright, so how can we make sure like the number we have already find in the right frequent is already in the left frequent? That is straightforward. We are using the same array, so that should not be the problem. And then by multiplying them, what are we getting is like count like how many villages of I exist on the left. So I mean the numbers in here, then we multiply and go through how many triplet. We can use this by using the J. So okay, so let me try to dry run through the HTML1. So since we have like numbers in here, so our right frequent will be like this, like 2 6 and then 3 1. So that is our right frequent after run through it. So since we find the 6 initially, we detect the 1 from here, and then we will find the pairs. How can we find the pairs? Like left frequent nums multiplied by 2. So 6 multiplied by 2 is 12, which is not exists. That began 0. So if that pairs began 0, we don't need to consider anything. So answer is originally 0. Or technically we are doing like 0 plus 0 modulo by mod, which is also 0. And then we're gonna update our left frequent by putting the 1 6 in here. And then we go to the next approach, which will begin like 6 3 and 6. Now is a 3. So we have now we detect the 3 from here. So 3 began the 0, and then we calculate the pair like 3 multiplied by 2, which is 6, is A6 in the left frequent. That's began the 1. And then the same for the right frequent, that is already AZ. Wait. No, that is not AZ. My bad. So since it's began to 0, so we are receiving the 0 in here. Because in the second iteration of the line number 12, we have detect the -1. So if began to 0, so 1 multiplied by 0, technically began 0. At the end, we add in the 3 into our left frequent. So let's begin like this. And then next step, we are going to remove the 6 in the right frequent, like something like began 0 in here. Yep. And then we are calculating the pairs like left frequency of num, which is now 6. Wait, let me check. Yeah, left frequency of num, which is num multiplied by 2. Num is a 6 now. 6 multiplied by 2 is a 12, and the default is also 12. Yep, at the end we got that 1 in here. Like, and pair will be 1 because our right frequent, even though there is no values in here, like 6. Yeah. So even though it is not in here, so we getting the 1 in here. That's the reason why we are receiving the 1. Okay, let's try to run it instead of like trying to dry run by ourselves. And then trying to submit. So the time and space complexity will be the O of n for both. Since we don't use any extra, we only use the one extra dictionary, which is to keep track of how many times the values appears in here. And the same for the space complexity. Yeah, that's pretty much it, and see you in the next one. Bye.